Alrighty, welcome back, boys and girls. It's your main math man, Mr. Shane, coming to you live from Alameda International High School. In this video, still working with solving these systems of linear equations, still working with elimination, but now we're going to say, okay, what happens when we can't just multiply by -1? We're still going to use those same steps as before, where we eliminate one of the variables by adding these two equations together, substituting back in one of the values that we find, and then solving for the other variable, so that way we could write our solution as an ordered pair. So always make sure you should end up with an x and a y value that you write as an ordered pair. So in that first equation, I have 5x plus 6y equals -8 and 2x plus 3y equals -5. So what I'm trying to do is I'm trying to find a least common multiple between these two values. So what I can do is this: I can multiply this second equation by -2. So what I'm going to do is multiply each term by -2. And you have to make sure you're multiplying each term, because a lot of people are just trying to, throw a negative on the outside. You gotta make sure you're multiplying each term. And the reason why I'm gonna do that is this. You can say I have a -4x minus 6y equals, and then a +10. The reason why I'm doing this is, if you notice, I'll have opposites with those y values. So I'm trying to make sure that my coefficients of one of the variables are opposites. Now what I can do is I can combine these two together. So I'm going to add the columns together. So I have 5x and 4x is going to be just 1x. The negative and positive 6y cancel out, so I'm just left with 1x equals 2. So real simple on that one, I already have my value that I need. So I'm going to say my solution point, again, x and y value, is going to have the x as 2. So now what I'm going to do is I'm going to take that value for x, and I'm going to plug it back into my original equation. So I'm going to substitute back into that first equation, and so what I should have is the first equation in terms of just y. So I'm going to say, all right, I have 5 times, so you use parentheses to show multiplication. So I have 5 times 2 plus 6y equals -8. So again, make sure you use parentheses to show multiplication when you plug in that x value. So again, I can simplify, so I have 5 times 2 is 10, everything else stays the same. Make sure you can get that variable by itself, so I'm going to subtract 10 from both sides. On the left side, the 10's cancel out, 6y comes down. And so on the right side, I have -8 and -10 is -18. Always make sure you see that last step. So I'm going to say my coefficient 6, so I'm going to divide both sides by 6. So I'd say my value for y is going to be -3. So now that I have my two values, I'm going to make sure you have a solution as an ordered pair. And so that means this. If I say my system of equations is that, I would have my solution, meaning where they cross, is going to be 2, -3. So that in the year turn number 1, make sure you can try it out for yourself. Pause the video for your own attempt. So it looks like this. I'm going to say, all right, I have second equation, multiply by -2. So same thing. I'm going to multiply by -2. And so what I can do is I can rewrite it. So I'm going to rewrite it under here. I'm going to have -6x plus 14y equals, and then I have 38. So again, make sure you're multiplying each term in that second equation by a -2. Now I can combine these two equations together. So I'm going to add the columns together, make sure one of the variables is eliminated. So that means this: I have the 6x and -6x cancel out. I have -2y and a +14y, so that means I have 12y, and I have equals, and then I'm going to say 48. Again, make sure you can use that Desmos calculator if you need to double check your values. Divide both sides by 12, and so I'm going to say y equals, so I'm going to say y equals, and then 4. Again, make sure once you solve for one of those variables, plug it back into your original equation. And you can use either one, so just make sure you pick one and stick to it. So that means this: when I substitute back in, again, make sure you use parentheses instead of your variables. So I have 6x minus 2 times 4. So make sure instead of 2y, I have 2 times 4, and I have equals 10. Again, just trying to solve for that variable x now. So I have 6x minus 8 equals 10. Add 8 to both sides. and then I'm going to say, all right, I have 6x equals 18. Divide both sides by 6 to get your value for x. So again, make sure you're just trying to isolate that variable, get it by itself, and then since I have those 2 points, meaning I have an x and a y value, I can write my solution as that ordered pair. So I'm going to say my solution is going to be at the point 3, 4. So now what happens, maybe I'm not going to have to use a -2 every time, but what I can do is this. I can say, all right, in that next example, I have 4x plus 2y equals 8, and I have 3x plus 3y equals 9. So I have a couple options with this. I can either multiply each term in the first equation by a -3, and then I'd have to multiply the second equation by a +4 because I'm trying to get one of the columns opposite of each other. So I'm going to say, all right, I could do that, or I could do a similar idea. I can multiply by a -3 to the first one and a +2 to the second one. As long as you're eliminating one variable, then you'll know you'll be good. So I'm going to, let's just keep it simple. Let's multiply by, let's say, so I'm going to multiply this one by, so multiply by, let's say, -3 in the first one, and let's do +2 in the second one. And the reason why I'm doing this, I'm trying to get rid of those y values so that way I eliminate one of those variables. So in the first equation, I'm going to rewrite it like this. I'm going to have -12x, so -12x minus 6y equals -24. And then I have to multiply my second equation by 2. So each term multiplied by 2. So I have +6x, I have +6y, and I have 18. Now what I can do, same kind of steps as before, combine those 2 equations to eliminate one of those variables. So I'm going to say, all right, these 6y's cancel out, so I'm left with -12x, and +6x is going to be -6x equals, I have -24 plus 18 is going to be -6. Again, you should always have those. Once you eliminate one of those variables, you should only have an equation with one variable in it. Always divide by the coefficient, so I divide both sides by 6. I'm going to say x equals +1. Take that value for your variable, plug it into one of your equations, and so I'm going to actually plug it into that second one this time since it's right there. So I'm going to say instead of x, I now have 1. So I have 3 times 1 plus, and then I have 3 times y equals 9. Make sure you can solve for your variable. That way you get an ordered pair. So I'm going to get that variable by itself, subtract 3 from both sides. I have 3y equals 6. Divide both sides by the coefficient. So I'm going to say divide both sides by 3, and now I have y equals 2. Once I have those 2 values, x and y, I can always, in order pair x and y, I can write my solution. So that means those 2 points, or those 2 equations, I should say, cross at the point 2, or excuse me, 1, 2. So again, those lines intersect at the point 1, 2. On the back, it reads like this. All right, let me make sure it's on here. So now it has same kind of setup. Again, make sure you're kind of doing this. So we want to make sure multiply at least one equation by a value. And when I say a value, I'm just talking about a constant. So that way you can kind of eliminate one of those variables. So in that, this number 1, make sure you can say, I notice, hey, I have some common multiples here, so what I could do is I can multiply the second equation by -3, or I can multiply the first equation by a -2. Again, either way would work as long as you get that same solution point. So what I'm going to do is I'm going to actually multiply this second equation by a -3. So each term by -3. So I'm going to have, let's cross it out, so I'm going to have a -9x minus 6x, or excuse me, 6y equals, and then I have +12. So let's make sure I multiply each term by a -3. The reason why I'm doing that, trying to cancel out one of those variables. So now I can combine them, again, trying to eliminate one of those variables, I end up with the x's canceling out. So that means I have positive 1y, negative 6y. So that means I have negative 5y equals, and then 25. So again, 13 plus 12, 25. Make sure you can divide both sides by that coefficient. So I divide both sides by that negative 5. That just leaves me with y equals, and then negative 5 as well. So again, always use those multiplication and division rules for those integers. Same sign, positive. That's why we have positive 1y. Different sign, negative. So that's why we have positive 1y equals negative 5. Take that value, plug it into your original equation. So I'm going to say, let's do that first equation. So I'm going to have 9x. Instead of y, I now have minus 5 equals 13. So again, everything else outside of that variable y stays the same. Make sure you can solve for that variable x now. So I'm going to add 5 to both sides. So I have 9x equals 18. Divide both sides by 9. And I have x equals 2. Make sure you can pick your two values for x and y, so that way you can have your solution as an ordered pair. So I'm going to say my ordered pair is going to be the point 2, negative 5. Again, make sure you can also, what you could do to make sure these two work is you can plug those two values back into each of those equations, and you should get a correct answer, meaning this. In the first equation, I have 9 times 2 is 18. 18 minus 5 is 13. So I know that that solution works for that equation. And then my second equation, 3 times 2 is 6. And I have 2 times negative 5 is negative 10. 6 plus a negative 10 is going to be a negative 4. So both of those work out very simply. So now on the second one, make sure you can multiply one of those equations by a constant. So I'm going to multiply that first equation by a negative 2, and so I'm going to rewrite it like this. I'm going to say, all right, I have, let's do negative 4x minus 2y equals, and then I have negative 46. So you can make sure you can use that Desmos calculator in case you get stuck on those integers. So now combine these two together. So I'm going to say I have negative 1x, the y's cancel out, and I have a, let's see, negative 9. So let's have negative 9. That just means divide both sides by the coefficient of negative 1. X is going to be positive 9. So that means I can take that value of x, plug it into your equation. So I'm going to say, all right, let's say I'm going to rewrite this second equation. I have 3 times x, which is going to be 9. So I have 3 times 9 plus, and I have 2y equals, and then 37. Again, just trying to solve for my other variable using that first value that we found. So I have 27 plus 2y equals 37. Again, subtract both sides by that non-variable term. So now I have 2y equals 10. Last step, always divide by the coefficient. So you say y equals 5 for this one. Once you have those two values, rate your solution as an ordered pair. So I'm going to say they meet at the point 9, 5. So again, make sure you can pause, rewind, replay any of those ideas for yourself. That way you can ask questions if you need them. In number 3, a little bit trickier. Notice how, it's not as simple as just multiplying one equation. I'm going to have to multiply both of these equations. So let's do this. I'm going to multiply this first one by a negative 3. I'm going to multiply this second one by a positive 2. So make sure when you do that, it's just like that distributed property. Make sure you're multiplying each term inside the parentheses. So I'm going to say, all right, this is going to be equal to, I have negative 18x plus, I have negative 6y equals, and then negative 6. My second equation is going to be 12x plus, and then I have 6y equals 16. And notice my objective is always trying to get rid of one of those variables. I'm trying to eliminate one of those variables. So whatever I end up multiplying with, again, you can choose that, but I should end up with just the opposites in one of those columns. So now what I can do, add these two together. So I'm gonna say, all right, I have negative 18x, positive 12x gives me negative 6x. The y's cancel out, and so I'm left with just, let's say, if we have 16, so let's do, that's why, okay. Okay, it should always be an integer value, so that's why I made a mistake. Okay, 4x, 2x, so that means 8x. There we go, a little bit better. So let's try this again. So negative 18x, positive 8x is gonna be negative 10x. And then we have negative 6, positive 16 is gonna be positive 10. Divide both sides by that coefficient of negative 10. And so we say x equals negative 1. All right, so again, anytime you get those points, it should usually just be an integer, otherwise you can go back and kind of fix it. All right, so now we can say, all right, take this value of x, plug it back into your original equation. Either one will work, so again, up to you to choose. I'm gonna choose that first one, so I'm gonna say instead of x, I now have a negative 1. So I do 6 times a negative 1 plus 2y equals 2. Make sure you can multiply, so I have negative 6 plus 2y equals 2. Trying to get that variable y by itself. And so I'm going to add 6 to both sides. So I have 2y equals 8. Divide both sides by that coefficient, so I have y equals 4. Two values, write your ordered pair for the solution. Number 4, same kind of setup. Notice how I already have a simple equation in that first one. So what I'm going to do is I'm going to multiply this first equation by 3. So that means I have to multiply each term by 3. So I'm going to rewrite it down here. I'm going to have 6x minus 3y equals 12. Again, the reason why I'm trying to do this, I'm trying to eliminate one of these variables. Now I can combine these two together, so I have 13x, the y's cancel out, and I have 39 on the right side. Divide both sides by the coefficient, so I divide both sides by 13, and I can say x equals 3. Take that value, plug it back into your original equation. Again, either one will work. So let me actually just do, let me do that second one. So I have, instead of x, I now have 3. So I have 7 times 3 plus, and I have 3y equals 27. Again, make sure you can multiply. So I have 21 plus 3y equals 21. Subtract both sides by 21, so I'm going to say, all right, 3y equals 6. Divide both sides by that coefficient, so y equals 2. Again, make sure you can write your order pair for your solution, so I'm going to say 3, comma 2. And always in the form of an ordered pair, x and y. And then on these last two, again, real simple. I'm going to say, let's see, for this second last one, let's do, I'm going to multiply this first equation. I'm going to multiply it by a negative 3. So let's multiply by a negative 3, and I'm going to multiply the second equation by a positive 2. That way the y values will cancel out because it will be opposite of one another. So I'm going to say this, let's write it down here. So I have negative 3 times 4x is going to be negative 12x. I have negative 3 times positive 2y is going to be negative 6y. And then I have negative 14 times negative 3 is going to be, let's say, 42. So let's say positive 42. My second equation, I'm multiplying by 2, so I have positive 10x plus 9, or let's say plus 6y. There we go. The whole reason why we're doing it, trying to eliminate one of those variables, and this is going to be negative 34. So we've got some larger numbers on here, but again, it ends up being a lot simpler once we eliminate a couple of these values. So I'm going to say, all right, I have negative 2x equals, and then I have, let's have positive 8. Again, it should always, once you eliminate one of those variables, you should only have one variable left. So now I can divide both sides by negative 2, and I'm going to say x equals negative 4. Take that value, plug it back into your original equation. So I'm going to do that second equation. So I have, instead of x, I have a negative 4. So I have 5 times -4 plus 3y equals -17. Make sure you can solve for your variable y now. So I have -20 plus 3y equals -17. Add 20 to both sides, trying to get that variable term by itself. And so that 3y equals 3. That just means y is going to be equal to 1. Make sure you can write it as an ordered pair. So I'm going to say my solution is going to be the point -4, comma 1. And then lastly, number 6, real simple. All I have to do, take this second equation, multiply it by a -2, so that way the x's would cancel out. So I'm going to say, instead of the second equation, I now have -2x minus 10y equals -4. Again, all you have to do, make sure you're multiplying each term by that outside amount. So now I'm going to combine these two equations together, trying to eliminate one of these variables. So I have positive 2x, negative 2x, those cancel out, and I'm left with -3y equals -3. Always divide by that coefficient, so make sure you're dividing both sides by -3, and so I'm going to say y equals just 1. Take that value, plug it back into your original equation. So I'm going to plug it back into that first one. So instead of y, I now have a 1. So let's do 2x plus 7 equals 1. Just trying to solve for that variable x now. Trying to get it by itself. Subtract 7 from both sides. On the left side, I have 2x. On the right side, I have -6. Divide both sides by that coefficient, so I have x equals -3. And once you get to that two-step equation, so it should be super simple. Make sure you write that solution as an ordered pair. So you're going to say -3 and 1. Again, make sure you're always writing that solution as an ordered pair. Again, be sure to follow those steps. You're going to multiply one of those equations or both of those equations by different values, trying to eliminate one of those variables. Once you solve for that variable, plug it back into one of your equations, solve for the other one, write your solution as an ordered pair. Again, be sure to ask questions as they come up, and as always, super slam that subscribe button.